Let's do some examples. First, a ball is dropped from a height of 5 meters. How much time will it take the ball to reach the ground? I'm given that it's dropped, so that means that my initial velocity is 0 from a height of 5 meters. So imagine that we have this height of 5 meters, and our object is going to be here, and it's going to be dropped, and it's going to fall down here. So let's let our initial position, our y initial, be 5 meters, and our y final be 0, the ground. So this makes our change in position final minus the initial negative 5 meters. So that I know that delta y is negative 5 meters. Now I'm looking for how much time it will take. Now remember, we have our freefall equations we can use. For this one, if I have delta y, I know the initial velocity is 0. I know that it is in free fall, so the acceleration is due to the gravitational field. Then I can use delta y equals v initial t minus 1/2 gt squared. My delta y is negative 5. My initial velocity is 0. Minus 1/2. I'm going to use 10 for g to make my math easy. And that'll leave a t squared. So now I can rearrange and find the time. So my algebra gives me a negative 5 will be equal to negative 5 t squared. So a negative 5 divided by negative 5 will be equal to t squared. So negative 5 over 5 is plus 1 would be equal to t squared. And then the time would be the square root of 1. Which is 1 second. Next, let's determine the velocity of the ball when it reaches the ground. Again, I know that the initial velocity is 0, and I know that it is going to fall from a height of 5 meters. So I can let the initial position of the ball be 5 meters, and the final position of the ball be 0 meters. I now know that the time it takes it is 1 second because I found that from up here. So if v final is equal to v initial minus gt for free fall, our final velocity will be equal to our initial velocity minus gt. I'm going to use 10 for t, and I substituted my 1 second from above here. So then my final velocity is negative 10 meters per second. Now remember, the negative sign gives me the direction. So right before it hits the ground, our ball is moving very, very fast at a velocity of negative 10 meters per second. Let's look at another one. This time an object is thrown upward with a velocity of 5 meters per second. So first I'd like to start by graphing this one. If I have a velocity versus time graph, and my initial velocity is 5 meters per second, and I know that it is on the face of the planet Earth where the acceleration due to the gravitational field is about negative 10, then I know that I'm going to get a line on this graph that will look like this. And that will be my acceleration. So I know that it's going to stop moving at the highest point, and then it will turn around and come back down. Remember, all of these velocities up here are positive while all of these are negative. So I know that the velocity initially is 5, positive 5. The initial is positive 5 because it was thrown upwards. I know that the velocity when it reaches the highest point will be 0 because it's going to stop and turn around and come back down. Our object's going to be thrown upwards and come up and come back down. So, what's the maximum height of the object? So that is, what will our delta y be? Now, I don't have time. That's what's not given. And this is why having that equation we derived earlier, where we eliminated time, is very helpful. So if you look back, our v final squared is equal to our v initial squared minus 2g delta y for a free fall problem. My final velocity will be 0 in this case because I'm just looking for when it gets to the highest point, which will be at this time right here where the velocity is 0. The initial velocity was 5, don't forget to square it, minus 2. I'm going to use 10 for g because it makes the math easier. And then I have my delta y. So then I'll have negative 25. 5 squared is 25, subtract it from both sides, is equal to negative 20 times delta y. Divide both sides by negative 20 and I'll get delta y, which would be equal to 1.25, and delta y is a measure of position, so it should be meters, 1.25 meters. Let's look at another. Now, how much time does it take this object to reach that highest point? Remember, the initial velocity was a positive 5 meters per second. Now, it's still going to have a final velocity of 0 at the highest point. I know that the acceleration is the acceleration due to the gravitational field, and I'm going to use the absolute value of our rate because I'm going to use the negative sign in my equation. Now, if I'm looking for the time, then if I use the v final is equal to v initial minus gt, remember that's the equation of the line. Remember, this is still just a velocity time graph, and we have our initial velocity at 0 seconds, and we're trying to find what is the time here, knowing the slope. Remember, the slope is that negative 10 meters per second squared. So then our final velocity, we're going to say 0 because we want to find the time when the velocity is 0. And so when the velocity is 0, that will be when it's at the highest point because remember, it stops and turns around and comes back down. The area above the graph here is positive, so the object's going up into the air. And then the area here is negative, so the object's coming back down. So this is going up, and this is coming back down. So if I go and substitute in my initial velocity of 5, minus, I'm going to use 10 for g just to make my math easy here. Subtract 5 from both sides. I'll have negative 5 is equal to negative 10t. So the negative 5 divided by negative 10 is t. So the time is 0.5 seconds.